Hello, and welcome to this video about independent events. Independent events, it's an important condition that we expect to find in events that are not influencing each other. So we said that two events are statistically independent if the joint probability of A and B can be computed as the product, the multiplication of P of A and P of B. So we are talking that we say that two events are independent if the occurrence of one of them does not have an influence, does not have an effect on the probability of the event that's happening later. So it's something similar to the probability of being late today to the classes and having, for instance, vegetables for dinner the day before. Theoretically, both events are independent. You can have whatever you want to for dinner, and this not affects the probability that you are late the day later. So if A and B are independent, this rule can be expressed in many different ways. If they are independent, we say that the probability of A given B equals the probability of A. Or, in other words, the probability that you arrive late today, given that you had vegetables for dinner yesterday, it's exactly the probability of being late today. The thing that you choose for having dinner does not have an event, does not have an effect on the probability of being late. And this applies in the same way if we change the order of the letters. B and A will be independent if the probability of B given A equals the probability of B. And of course, we need to work with non-impossible events. We are always referring to events whose probability is not null. There is some probability that each of these events happen or not. So there are three basic rules that I would recommend that you study a lot and you try to remember, because it's quite typical that you need to check whether two events are independent or not. The most basic one are these three, which is the probability of A given B is the same than the probability of A, which is quite intuitive and easy to remember, and also the idea that the joint probability between A and B equals the product between marginal probabilities. And as you remember, there is another case when events are not independent, when you can compute conditional probability, where you can compute the joint probability, the intersection, the product, wherever you refer to the third line, you can compute to the joint probability of P and A as some expression combining the conditional probability of A given B per probability of B. So it's very important to realize, to be aware that this third line, the multiplication rule, will change depending on events, whether events are independent or not. And these three rules are the most basic ones. And once you remember these three rules, you can obtain any of the 5 remaining expressions that relate the probability of no A, no B, B given A given B. All these expressions can be obtained using the 3 previous expressions. And I invite you to try to obtain these 5 expressions from the 3 previous lines. So let's go back to the example we introduced in a previous video. This example about the car lot, and there were some percentage of cars that had Bluetooth and 40% had GPS and so on. So the question that we need to answer now, it's here, are GPS and Bluetooth statistically independent? So what we need to answer is whether the probability of GPS given Bluetooth equals the probability of GPS. They are not influencing each other. They are completely independent. Maybe we have an opinion about that, but remembering the data that we reviewed before, you may have an idea of what's going to result. So, this was the cross table we built in other video. So, what we need to do is to check whether the probability of the joint intersection between both events, which was, by the way, 0,2, as you remember, it's written there, 0,2, equals the product of marginal probabilities. So, remember that we can obtain marginal or simple probabilities from the margins of this table, as probability of GPS was 0.4 and probability of Bluetooth was 0.7. So, to conclude that both events are independent, we need to check whether the product of these two, which was 0.7 per 0.4, equals the joint probability that was given in the problem. So, what do you see here? What's your opinion? Are they the same? No, they are not the same. You can see here that the joint probability, which was 0.2, and it was written in the slide at the top, is different from the product of marginal probabilities, which is 0.28. So both numbers do not match, and this is an evidence that both events are not statistically independent. Maybe we can refer in colloquial, in informal language, whether something is independent or not, but the concept, the idea of being statistically independent, means the accomplishment of this rule. If the numbers are not exactly the same, we conclude that they are dependent. So this means that it makes sense to compute conditional probability. And this is in line with the previous conclusions in other video. If we are able to compute some conditional probability, and this conditional probability is different from the marginal probability, this is another evidence that events were not independent. So with this, I finished this example about independent events. I recommend you to practice a lot with these exercises, and if you have any doubt, please write me, or we can organize a Teams or any other way of meeting. Thank you.